Okay, I'm going to test the STARLINK Mini wall wart here that puts 120 volts in, and it puts out 30 volts DC. So it says on here input 100 volts to 240 volts, 1.6 amps, 50, 60 hertz. Output 30 volts DC, 20 amps, 60 watts, made in Vietnam. So we're going to go ahead and test this, see what the output is, just for kicks. So we've got the STARLINK Mini wall wart plugged into a kilowatt meter here. Got a bunch of junk around here. Aluminum blades, brick rule, old pistons. And we're going to go ahead and measure it here with the KIKUSUI electronic load, PLZ. This is a 4W series. We're going to go ahead and measure the output characteristics of this wall wart. So we're kicking on the KIKUSUI here. And we're going to put this into constant power mode. Now we're going to go ahead and we've got an input voltage here of about 119.4 volts. Got no current right now. So this is the input voltage AC to the wall wart. The output of this is nominally 30 volts. We've got a big bunch of the stock wire for the STARLINK Mini, which is like 50 feet. And we've got it connected up to the electronic load here, KIKUSUI. And we're going to go ahead and kick this on here. This turns the load on. I'm going to go ahead and measure the watts here. So we're going to go ahead and kick this load up here to 5 watts. We got 29.7 volts, 0.168 amps. We got 5.6 watts as input in AC. We're going to go ahead and kick this up to around 10 watts DC output. Again, this electronic load is DC. Got 10.08 watts DC, 29.5 volts, 0.34 amps. Got 11.1 watts. Let's go ahead and open this up to 15 watts. This is the DC output after 50 feet of line here. You got about a half an amp, 29.3 watts at 16.8. Let's go up to 20. Now 20 watts is roughly what the idle of the STARLINK Mini is. Just sitting there not doing anything. So there you get about roughly keep on turning this up. You get like I'm chasing my tail there. 29 by 20, roughly about 20 watts. Got about 22 in. You get about 2 watts loss. Pretty good, actually. Must be a switching supply. Let's go up to about 30 watts here. And it kind of like end up chasing my tail here. Here you get about 31 watts roughly. Got about 34 here. Not necessarily entirely stable. Let's go up to about 35. Let's go up to 40 watts. Let's go quick. Keeps on mushing into that should offer you about 40 watts. You get about 45 watts roughly. So you get about 5 watts loss at 40. Let's go up to 50 watts. We're going to turn this here. So this electronic load is equivalent of like having a bunch of resistors, but it's done electronically with transistors. It's roughly about 50 watts. We got about 54 here. Then we're going to go up here to 55 watts. And we get about 59. So we got about 4 watts loss. Let's go up here to about 60. You can have happening here is you got the heating of the wire. Turn this backwards some. It's 60.7 watts. Got about 72 here. And see if we can back this off. This can happen when you got heating up a wire. Active circuits. It's roughly about 60 watts there, and you got 70 watts. You're losing roughly about 10 watts. And boost this up some. There's about 60, about 70. Losing about 12 watts, roughly, at 60 watt output. So if you could run this just off DC with batteries or something, you'd save 12 watts if you're trying to run off the grid or something like that. Again, this is a KIKUSUI PLZ164WA. A means it'll go down to lower voltage. This goes from 0 volts to 150. I think the non-A model starts at a couple volts. This one will go down right to 0. It's got about 30 volts. 30 amp load, 165 is the total number of watts this can handle. So we got about 60.2 watts here. Got about 71.8. Kick this thing way down here. Let's go back to about idle. Let's see what it does. You chase the tail here some. About 22.3 watts, and we got about roughly about 20. Moving this knob down is changing the effective, the equivalent of if you had to make this thing out of resistors. It's like a big variable resistor, but you've got a transistor in there. This is again the KIKUSUI electronic load. This is a 4W model. The current one is a 5W. And I just boost this up some. Losing roughly about 2 watts at 20 volts. And that's an aluminum blade there for cutting plexiglass. That's for bricks. Those are bananas. That's Miss Locklear there. And this is the electronic load, and I'm going to turn this off. Got a little bit of, goes into minus because it's probably not totally calibrated. You got a bunch of different ranges on here. Got one range goes up to 1.6 watts. One goes to 16 watts. One goes to 165 watts, which I used for this test. Again, this is the STARLINK Mini stock wall wart and the 50-foot cable, and it's hooked up to an electronic load. I'm characterizing this wall wart, which is a switching device.